5-4A, factoring polynomials, the difference of two cubes. Once again, this occurs when we have a binomial, which we have here. We're also going to be using cube roots. So we'll be using this function on your calculator. So what we need to remember is that everything needs to be a perfect cube. So let's work on h to the third power, which is a cube, plus 8,000. Remember when we did binomials and they were squares, we could only do subtraction, but we can both do subtraction and addition. So we're clear to use both symbols. Alright, with the variable of h and it's to the third power, as we learned with square roots, they undo squares. Cube roots undo cubes, so that'll just give us h. What we need now is to check with our calculator, is 8,000 a perfect cube root, and you're going to plug it into the calculator. Turns out that it is a perfect cube root, so we do have the sum of two cubes. So we're going to use the pattern that you see right here in the pale yellow, and we're going to deconstruct or find the solution. So since we found out that h to the third power, when it's cube rooted, is h, that'll give us our first part of our binomial that's right here. So there's our h. And then because it's a positive, I'm going to put a positive right here. Our second part, of course, is that the 20 goes next because that was the cube root of 8,000. All right, what do we got to do next? Put it in parentheses. You can see the pattern here has, of course, a trinomial. And how are we going to build that trinomial? Well, we're going to forget what's up here and we're going to focus in on what's here. So what we're going to do here, follow the line here, is we're just going to take that h and we're going to square it. So h squared is h squared. Next up, we're going to take that 20 and we're going to do almost exactly the same thing, but we're going to bring it to this part. So we're going to square the 20, and when we square 20, the calculator says 400. If you look at the pattern for addition, it says that the h squared, the sign should be a subtraction, and the last term should be a positive. What we got to do now is find this AB term, or this middle term, and it's quite easy. We're going to take these two numbers, h and 20, and multiply them together. So h times 20 is 20h, and we're just going to go ahead and place that right there. And you can see I rewrote the answer right here a little bit cleaner. Alright, you can see we have another binomial, and we have a t cubed, so it's probably a cube. We know that in order to undo a cube, we cube root it, so our answer is a t. Then we're just going to go ahead and check to see if 8 is a perfect cube. Plug it in the calculator, and it has 2. So we do have cubes. What we do have is subtraction, and we're allowed to have subtraction and addition with cubes. Now that we found the answer what t cubed is, which is t, and we found out the cube root of 8 is 2, and if we look at the pattern over here, subtraction, we keep it subtraction and we put it inside parentheses. And of course, the pattern is the same. We're going to have to build a trinomial. Alright, let's go build that first term of a trinomial. So we're going to take this t and we're going to square it. So t squared is t squared. Now we're going to build the last part, or the caboose of our trinomial right here. And we're going to take that 2 and we're going to square it. And what is 2 squared? Calculator says 4. Now according to the pattern for subtraction, this sign is a positive and the last one is always positive. What we have left is the middle term, and how do we get that? We take these two numbers and we multiply them together. So we're going to take t and times it by 2, and we get 2t. And we're just going to place it right here in this spot. 2t. And that is our final answer. Alright, we have a binomial, but is it a cube or is it a square? Well, it's neither. So where you see our direction says factor it completely. If not, it's not factorable, and most students would write prime. But if you ever write prime, you probably haven't checked for a GCF. Let's see if we can GCF before we try to write the word prime. I see in my binomial that the first term has an x and the second term has an x. So yes, it has a GCF. But what is the GCF? It's x. Now I have to look at the exponents, and I can't take the larger one, I have to take the smaller one, so it's x to the first. So we're going to remove, by division, an x. And if you remember with GCF, the opposite of division is multiplication, so we're just rewriting it. So I'm going to say 8x to the fourth power divided by x gives me 8x to the third. And if I take that GCF again and go x divided by x, it gives me 1. Now let's check. Let's see if this 8 and this 1 are perfect cube roots. The cube root of 8 is 2. Let's check if the x to the third power is. It should, because a cube root cancels out a cube. So we've got an x. So now we have a 2x. Then we're going to have to see if 1 is a perfect cube root. Plug it into the calculator and it says 1. So we got 1 right there. So we got the beginnings of our pattern. Now let's go ahead and build the trinomial. Once again, we're just going to focus in on the binomial here, and we're going to take this and square it. We're going to square the 2 and we get 4. And we're going to square the x and we get x squared. So there's our 4x squared. Then we're going to take the 1 and square it, which is just 1, and we'll put it in the back. Because we have a plus sign here, that means we're going to put a negative sign. And if you haven't noticed, the last term in a trinomial is always positive. Now I got to build my middle term. And my middle term, of course, comes from taking the 2x and multiplying it by 1, which is just 2x. So you can see that our GCF is involved in the answer. Here's the binomial from the pattern, and here's the trinomial. So this is our final answer. Alright, our last problem is a binomial. It's not a square. One of the reasons why is because the m is cubed and the n is cubed, and also squares we can only use subtraction. It is only in cubes that we can use both. So we're going to cube root. So we know that the cube root of m to the third is m. So that's the first part of our binomial. Then it's a plus, so the pattern says if it's a plus, it stays a plus. We've known from the previous problems that the cube root of 8 is 2. And don't forget the n. The cube root of n cubed is n. So there's our first part of our binomial. Now we got to build the trinomial. We know from the previous problems we're going to take this m and square it. And we know that the third term in our trinomial is when we square the 2, so that'll be 4. We also square the n, so it's n squared. And we'll place that in the back, so that's 4n squared. We just need to build the middle term, looking at the pattern. If it's positive here, then it's negative here. And the last one is always, always, always positive. So let's just finish up. And what is the term? Well, we're going to take 2, multiply it by the m. We're going to multiply it by the n. What do we get? In alphabetical order, 2mn. So there you go, ladies and gentlemen. The sum of cubes.